Can anyone square x minus 3 squared, please? We discussed this a week ago.
Would it be x squared minus
2 times the first times the second.
Minus 6x.
Perfect.
Plus 9.
That's it. Good. So we are trying to solve this equation. Of course, I'm subtracting x squared from both sides. I'm moving 2x to the other side. It became negative. I'm moving 9 to the other side. It became negative. So then I get x equals 1. So the equilibrium point has x equals 1, but this is not enough. It's a point. So I only determine the x value. How do I determine the y value?
You plug the 1
Yes,
into the equation.
exactly. How much is 1 minus 3?
-2.
How much is negative 2 squared?
4.
That's it. So we determine the equilibrium point. So for these two functions, here it is the equilibrium point, 1, 4. And you can say, why did you do all this work? Why didn't you just read it from the graph? Because I had to make sure that that's the case. We can, let's look at also something with radicals. So let's also look at 83. Is that okay with everyone?
Yes.
So
Yeah.
5 minus x. Can anyone tell us what type of function is 5 minus x?
Linear.
Thank you. Can anyone tell us what type of function is this? Read it and you will know what it is.
Radical.
Radical, very good. Square root, perfect. So in order to determine the equilibrium point, I have to set the demand equal to the supply. Maybe I should have said this here also. I did it, but I didn't write the initial. Good. So the left-hand side is 5 minus x. The right-hand side is the square root of x plus 7. How do we solve such an equation? Can anyone guess, wild guess, I should say informed guess better? What do you think? What should we do? Anyone has an idea?
I would say get rid of the square root.
Say it again. Yes. How do we do that? Yes. We want to get rid of the square root. I agree. How do we do that? What should we do to both sides to get rid of the square root? Very good.
Divide both sides by 2.
Remember, the square root is power 1/2. In order to eliminate power 1/2, I have to square both sides. It's the only way we can get rid of the square root, by squaring both sides. Can anyone square left or right? We need both. Can anyone square the left?
I can.
Please.
Would it be 25 minus 10x plus x squared?
Excellent. Can anyone square the right-hand side? Anyone, please.
It would just be x plus 1/2.
Of course. Of course. Very good. Okay, moving on. This is what type of equation now?
Quadratic.
Thank you. Quadratic. I need everything to one side, simplified, combined like terms, 0 on the other. X squared minus 11x. 25 minus 7. I'm fine if you use the poly feature in the calculator. I don't have a problem with that. It's too easy because it's x minus 2 and x minus 9. What are the options? X equals and x equals. You can use the poly feature, you can use the quadratic formula, you can use anything. This is arithmetic, I'm not worried about it. Can anyone give us the options?
X equals 2, x equals 9.
Excellent, indeed. Either 2 or 9, perfect. Now, whenever we square, so here's a note for you. When we square both sides, it's a must to go back and check. They may or may not work. They definitely work here, they work here, they work here, but they may not work in the original problem. Okay? Must check solutions after squaring both sides. It's a must. We have to. What was the original equation? Not this. The original equation is this. So now I have to check and see if, where, what. So I'm checking 2. 2 plus 7 is 9. The square root of 9 is 3. 3 equals 3. Yes, I'll say yes. I'm checking 9 right now. 9 plus 7 is 16. The square root of 16 is 4. But 5 minus 9 is not 4. No. No. So the only equilibrium point is 2 comma what? Is anyone paying attention?
X.
X is 2. 2 comma. How did we get
3.
the exactly? 3. 5 minus 2 is 3, or 2 plus 7 is 9. The square root is, yes, correct. So therefore, we're looking at this 2 comma 3. 2 comma 3. Okay, I think we had enough, so we can finally start chapter 1. At the end of chapter 1, we're going to have our first test. So chapter 1 is full of a lot of things. I'm not going to even put the title in because we're not there yet. But anyway, so in section 1.1 and basically 1.2, we're talking about something called limits. So what is a limit? A limit in plain English is, so the limit of a function is the tendency. What is another word, a good word for tendency? Target. Inclination, if you want, of a function. I'll put comma. Not the function value. Not the function value. So let me give some examples, and then I have some graphs to look at. Okay. I'm coming back to a function that I just prepared us. Can anyone refresh our memory? What function is this? We graphed it a few minutes ago.
Rational?
Yes, the simplest in this case, y equals 1 over x. Perfect. So what does the limit mean? A few examples for this. We already identified them, but I didn't tell you what they were. So the limit LIM of this function when x approaches infinity. So let me write this for you in words. Limit of 1 over x as x approaches CHES is there. They're there, but you can't see them. Sorry. As x approaches infinity. So I'm going to write it again. Limit as x approaches infinity from this function. X goes this way. And follow the function. X goes this way. And the function gets closer and closer, closer and closer to what value?
Positive infinity.
One more time. We read the y values from the y-axis, not from the x-axis. Okay, one more time. As x gets closer and closer to infinity, the function values get closer and closer to which number? On the y-axis, we read the function values.
0.
Indeed. Excellent. Limit as x approaches negative infinity of 1 over x. I started with this example because we already talked about it. As x approaches negative infinity, the function values get closer and closer, closer and closer. The tendency, not the actual value. The tendency, the target is what do you think? Should I?
0.
Yes, of course. And as you know, you may remember, I hope you do, this is called y equals 0 is a horizontal asymptote. So what is this all about again? Please understand, I'm not asking for the function value. I'm asking for the target. I'm asking for the tendency. So I printed out from the book on page, let me write the page number. Where is the page? The page is 113. So we have a few questions here. Of course, I'm going to scan this and send it to you. So here's a function. And we have several questions to answer about this function, about this graph. So when we look at -2, is this big enough? Can you see? Or should I open the book?
I can see.
Okay. So I would like to ask first question on this graph. How much is f of -2? F of -2.
2.
F of
1.
negative, careful, we are looking for full points. F of -2 is indeed 2. Awesome. One more quick question. How much is f of 1?
4.
F of 1 is indeed 4. Excellent. One more quick question. How much is f of 3?
Is it
Is that 1?
F of 3.
is it undefined or
We call it D&E. It does not exist or undefined. Excellent. Perfect. Notice that these have nothing to do with the limit. I just wanted to have these on the side. These are function values. Function values. Function values is not the same with the target or the tendency. This, we're going to complete it now, is the target. The target does not equal, it may, but not necessarily, may or may not equal the function value. So this function is called h of x. We're asked, so let's read, to find the limit of this function as x approaches -3. I need to explain something before we look at it again. So the limit as x approaches a number from f of x, this was different because it's infinity or negative infinity. This is read x approaches a from either side, meaning something like this. We are approaching from either side. When we are approaching from one side, we're approaching from the right, for example, or we're approaching from the left. This one says approaching from either side simultaneously. So therefore, coming back to our graph, this says, find the limit of the function as x approaches -3 from either side simultaneously. From either side, I need something smaller. From either side, -3, from either side simultaneously. What is the target, which may or may not be the function value? So as x approaches -3 at the same time simultaneously from either side, what is the function value? I should say the target value, not the function value, because it may or may not be the same. What will you say?
0?
Exactly. It happens that it's the function value as well. Fine. Moving on to 42. This is a different question. It has a different symbol. Let's discuss the symbol first. So we can have limit of f of x as x approaches a with a power that is not a number, just a symbol negative. This is only from the left-hand side. So this means x approaches from the left-hand side. And of course, this notation will be what?
Right hand side?
Yes. X approaches a, value a, from the right-hand side. Okay, coming back here. Limit of h of x as x approaches -2 from the left. From the left. So here's -2, and here's from the left. The function the ax values are getting closer and closer to -2. Now the function values. So x approaches -2 from the left, and the function values get closer and closer closer and closer to what target?
Undefined.
Exactly. Target, not the value. I don't care about the value. We're talking about the limit. We're talking about the target. Limit of h of x as x approaches -2 from the right. -2 from the right. Target value. What is the target value?
1.
1. Notice one thing. Now they're asking us what happens when x approaches -2 from either side. Here it is. X approaches -2 from either side. Target value for the function. What is it?
1.
1. Perfect. Limit of a function as x approaches 1 from the left. One from the left. Target. What is the target? X approaches 1 from target.
4.
4. It's on the left-hand side of 1, right? So this is 4. Now let's look at the right-hand side. X approaches 1 from the right. Target.
Two.
2. And now I'm going to ask you, I'm going to add here, what is the limit as x approaches 1 from either side of h of x? As x approaches 1 from either side,
Does not exist.
thank you very much. I cannot give you a number. They're not the same. Here they were the same. You were able to give me a number. But here they're not the same. So you cannot give me a number. If you cannot give me a number, the limit does not exist. It does not exist. The limit does not exist. So what have we learned so far? Here's what we have learned. Limit as x approaches a, either from either side, or from the left, or from the right, doesn't matter, from f of x is a number. L, a number. If you cannot give a number, the limit does not exist. It must be a number. If it isn't, like in this case, you couldn't give me a number. We couldn't determine a number because from the left and from the right, they're not the same. So in other words, I could say the limit as x approaches a from the left must equal the limit as x approaches a from the right for the limit to exist. For the limit to exist. I know I have to stop. I will stop in 1 second. So this is on page 113. So I picked this problem because it looks, no, not this one. Which problem did I pick? Oh, this one. I picked this one because it covers pretty much everything. And as you notice, So here we have our piecewise defined functions again. They're asking us to graph them. That's why I did them from the very beginning. And then we're asked to determine some limits. And then in the next section, we're going to look at functions without having the graph and the numerical way of determining limits. Any questions? So please complete R.5 and start working on 1.1, please. You do not have everything. We don't have everything in 1.1, but you can start working on 1.1. So as I mentioned, 8 of you have done very little, and I'm concerned. And we also have our star. She's in the middle of the chapter. She's almost finished. I love that. Thank you. And I will scan the papers, send everything to you. The videos will take a while, a little bit, for uploading. I think I have everything in order here. And thank you so much. Please stay if you need any help with anything. Please. Our first test is 2 weeks from today. Let me see. No, I'm lying to you. It's 1, 2, 3, 4. 4 meetings. So we have to finish chapter 1 in 3 meetings plus 1 meeting review. So it's on the 23rd. I did not create the test in Register Blast, but I will create it either today or tonight or tomorrow. So everyone can start registering. If you have any difficulties, let me know immediately. Okay? For September the 23rd. Any questions?
Have a good night.
Have a good night. Any questions for me? Anyone?
Thank you.
Thank you. Thank you, Jess.
Have a good weekend.
Have a good weekend. Thank you.
I have
Please.
a question.
Yes.
Can you like put that graph back up? real quick?
Yes. Yes. This one?
Yeah.
Yeah. Yeah. Let me switch the camera. Yes.
Okay, so I noticed like for 41 and that also actually